Okay.
Okay, so let's do like a 1 minute intro and then we can get started.
Yep. Um,
And you don't have to share like personal details or whatever. You can share whatever you want.
okay. Yeah. I am. I am Gene. So I've been working in engineering for last 4 years. I've been actively looking for job right now. Yeah, and happy to be in this coding interview.
Okay, cool. Sounds good. Okay, so the first problem I kind of made up, but I think it's a good one. So let me write it in. And it won't be like, it'll be pretty open-ended. So the first one, basically, you're given two numbers as a string, and you need to add them. So the numbers can have decimal or not, and that's basically the only criteria. And so you need to return the output that is a string as well. So return a string here. You can write some examples if you want, and ask anything clarifying.
Yeah, right from the start, I want to question about what does it mean it can have decimal or not. It means like it can be float.
No. So it can be like this. 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 Anything.
Yeah, and this input is given as a string, I assume.
Yeah, so you're given two strings.
Okay. So in this case, let me just reuse it. So let's say we have like first one string like this and the second string like this, and as a result, so the input gonna be something like that, and then the output should be also the string, and it should be like 2 6 2 6 6 no 2 4 6. 2 4 6. Do I have to add decimal point?
Yeah, so let's say whatever decimal I give you, that's the precision I want. So let's say we don't have this 1, 2, 3 point something. So we can have numbers, or we can have numbers with a decimal, and then the precision I want at the end is it's up to you. So if it's 246.0, you can either return 246, but if it's like like 123.1 plus like this point this, I want like the full thing as a string. So you can get rid of the trailing zeros if you want, up to you, or you can just return either one's fine.
Okay. So it sounds like one of the complications for the famous problem when we don't have like decimal points, and my approach right now gonna be to try to reuse that approach and see how it's gonna work in this case.
Okay. Not familiar with the famous problem, so you could walk me through it, I guess.
Yeah. So the simple idea is that let's say we have this 1 2 3 and then 2 4 5. That's maybe 6, and then the solution is like to have two pointers, one pointer pointing at the first number, or like at the first string, and second pointer pointing at the second string, and start moving them from the right to the left, and then have an interim variable as a carry, and then have convert the last. In this case, convert the last value I have if I have not run out of the characters in the first string. So I'll have this 3 converted to the 3 integer, and then I'll have the last character in the second argument 6 converted to the number, and then I'll add them 3 plus 6, and then do mod 10, and then record the result into a result string, and the carry gonna be 3 plus 6 divided by 10. Yeah.
Okay, got it. So I think I get what you're saying. So you're basically gonna add them one digit at a time with a carry, and you're gonna like reuse the carry, and you're gonna start at the rightmost digit, right?
Yeah. And then if I can continue doing that and move the first pointer, like first argument pointer and first string pointer and second string pointer, whenever I run out of the characters, I can still continue moving the second pointer. Or say I run out of characters. In this case, I'll run out for 1 2 3, and then I'll still have like 2 left. And then whenever I run out of characters, I keep the pointer and like indicator that like I have like the first pointer gonna point at like say -1, and the second gonna still point to the 0 index, and it means that I should just reuse the character from a second string and like use whatever I have left in the carry and like still continue recording to the output.
So I get the general idea. So let me ask you, so if you start at the right here, what would that work with an example like this?
Yeah, so right now, if I just start, I need to somehow adopt the decimal part, yeah, because like if I'm gonna start like right now, if I'm gonna start adding numbers, like I'm gonna start adding like 4 plus 4, and it's like clearly not right, because like 4 from the first is like actually the integer part, and 4 from a second is like decimal part, yeah. And I keep messing, I will mess up the result. And this way, I need to figure out how to adopt this mechanism. So it seems like they should be the same carry, but it should be like also account for the dot, yeah. And say we have like in the first one, we have a dot. Like in the first one, we don't have a dot, and the second one we have a dot, yeah. And that's that might be indicator that I should. And again, like let's say I have other example, like something like this, dot 1, 2. And the same, in this case, I have dots in both arguments, but I should kind of add additional 0 to the end to be able to apply the same approach, yeah, as I did before. So like if I add 0 in the end to the first string, I will be able to start adding one by one this number and record the output. Yeah, and in case I have a dot, I can record the dot also. So my idea would be to find this dot. Yeah, like brute force solution. Given whatever I said right now, to find this dot, if we have like dot present like in first and second or in both, and then find the index of the dot, and then kind of add zeros to the one that's lacking the numbers, yeah, and like kind of modify it in a way that it satisfies the requirement. And then I can start like if I normalize those two numbers, or like two strings, I can apply this previous methodology when I have just a carry and like add 1 to 1, and then like record the output.
Okay, so just to make sure that I'm understanding, so you're going to normalize them to like line up at the decimal, you're saying, basically?
Yeah.
Like,
yeah.
Okay,
Yeah,
and
so
then you're going to do the carry. Okay, got it.
Yeah. So the plan is the following. So I want to first find the dot index in first argument, find the dot in second, compare if numbers, if decimal, let's say places, or like decimal parts have different sizes, and then if they have the different sizes, I wanna normalize them. Like whatever has less, I need to add zeros to the end. Yeah, add zeros, normalize args, and then apply carry algo I discussed before with adjustment for the dot. So in case I see the dot in the pointer 1 and the pointer 2 points on the dot, I just gonna record that into the output. And because I normalized the decimal points, they're gonna be like pointing to the dot in the same time. So adjust for dot, and then record the output, and so like return output.
Okay, got it. And then basically, whenever you hit a dot, you'll just like write the dot because it lines up.
Yeah.
And you'll like skip. Yeah. Okay.
It's gonna line up because I specifically normalized two arguments so that like they have the same number of decimal digits, and I always can add zeros to the end whenever one is shorter than the other. And then the time complexity for this one gonna be, so for the first one I have, I need to find a dot. So it's gonna be of, let's say we have length of the first argument is gonna be n1, and then length of the second gonna be n2. And then I need to find the dots in the first and the second, so it's gonna be n1 plus n2 time complexity. And then I need to re-add the number of dots, so the range is of that, the time complexity here is going to be also there. I can assume have like upper bound for this one, and then apply the carry mechanism. So here are going to be whatever max, I would say, max n1 and then n2.
Yep, I got it. Okay, we can start coding. I think this is pretty clear. If you're happy with it.
Let me code the solution. So let's say we have this API for the problem, and we have let's say class solution, and then we have def add, and then we have arg1 as a string, and then arg2. And here I wanna, so I didn't ask that constraints. I assume that it's limited enough to be fit in memory.
Yeah.
Okay. So
yeah, it's not going to be like a stream of numbers or something. Yeah, you're fine.
Yeah. Okay. So it's going to be arg1 and arg2, and I assume that can I assume that one of them, like they both are kind of not none?
They're both what? Sorry.
So should I account for the non-values as argument 1 or argument 2?
No, you can assume they are real numbers. You don't have to assign. You don't have to look for weird stuff, and you can also assume. I don't think you asked, but you can assume they're positive as well.
Yeah. So I'm not familiar with looking for the first index for the dot. Let's say we have this find function in Python.
So since you can't run your code, you can make up a name of a function, and we'll pretend it gives you what you need.
Yeah. Let's say arg find function will find the first occurrence of the dot of the character or like string that I passed.
So this will give you like the index, right?
Basically. Yeah, the index. And let's say it returns none if it cannot find it.
Sure.
So like let's say index 1 equals index, and then I want to find index 2, and then apply the same. So I wanna check if either of them have dots. So let's say if index 1. So I wanna like save some time here and like figure out if there is any kind of shortcut here. So let me go a long way. Maybe I can optimize it later. So if index 1 is not, so let's say I have add the zeros equals let's say initially we have a zero add zeros parameter, and say let's have if index 1 is not none, and index 2 is not none, I want to have this mean. So like I want to calculate first the number of zeros. So the number of zeros is going to be, so let's say we have len arg1, and then if we have index of the first of the dot, so let's have this quick example, 1, 2, 1, 2, and then 3. In this case, the index of the dot going to be 0, 1, 2. Dot index 2, and the len going to be equals 4. So the number of zeros is going to be len minus index of the dot minus 1. So it's going to be index 1 minus 1. So maybe add 0 is going to be something like diff. So it's basically going to be diff between those two numbers.
Mm-hmm.
Let me make it more cleaner. Let's say
Sure.
zeros, 1, z1, and then z2 equals this one. And then I want to check at 0 is going to be abs z1 minus z2. And so here I'm still need to figure out, okay, do I need to add zeros to first or second? Yeah. And yeah, that's give me, I don't need basically. So if index 1 is not none, and index 2 is not none, so I need to, it's not none. So let's, so add zeros probably is redundant here. And I wanna figure out if I need to add zeros to a first one or a second one,
Right.
yeah, or I can just skip, yeah. So I need to add zeros if the index.
So to make it easier, why don't you just add a decimal if it doesn't exist to both of them, and then all your logic is the same? So if it's like 123, you can just make it 123.0 if you didn't find the decimal, and then all your stuff should be just one case, right?
Oh, okay, yeah. So let's if is not none, let's go. If is none, then I'll add arg1. And then it's going to be in the arg1 that, and then if, and then two. So the index gonna be gonna be n. So the number of zeros gonna be I'm gonna have like this z1 equals 0, z2 equals 0, and then here number of zeros gonna be z1 equals 1, and then if index 2 is none, then I'm gonna add this one to arg2, and then update the 0, 2, and then I just need if z1 is less than z2, then I need to add zeros to the second one, and then I need to do while let's say have add zeros equals z2 minus z1, and then while add zeros greater than 0, I'm gonna add arg. So I'm gonna do the same, almost the same line, and then I need to decrement number of. Oh no! So that's basically, so if z1 is less than z2, I need to add zeros to z1 until they are normalized, and then else I need to add zeros to the to z2. Then be z1 minus z2, and then do the same, but for the arg2. And then here I need to add zeros decremented. That's one. And then here arg2 if zeros greater than 0. Yeah, and here also the same. So like we have z1. So I'm adding that to arg2, and then I'm decrementing the number of. Again, like this can be moved to a separate function, and I can push the string there. But that's
okay. Let's just get a solution first.
Yeah. So now we have like normalized string, and we can do the carry and then the pointers. And say we have we start we have carry equals 0, and then I'm gonna start. So pointer 1 equals len arg1 minus 1, and then pointer 2 pointer 1 pointer 2 equals len arg2 this one, and then while carry is greater than 0 or pointer 1 is greater than or equal 0, and or pointer 2 is greater or equal 0. So I'm gonna do okay. So res equals, so we have interim res, let's say, so let's say kind of number or like digit equals carry plus integer. So here I need to check if the pointer is in out of the bounds, like if it's like equal -1. So in this case, I'm gonna check if pointer not equal -1. I'm gonna do integer and then arg1 pointer, and then else can be 0, and then plus else plus the same here for the arg2, and then can be pointer 2 if the pointer 2 is not equal -1, and otherwise 0. Again, like it seems like a little bit verbose. I will because I need also to move the pointer if it's not equal 1. So I'll have this carry, just carry, and then have condition.
Sure.
If pointer not equal -1, then I'm gonna do adding it to the digit, then particle, an integer here, and then decrementing the pointer minus equal 1, and then if pointer not equal pointer 2 not equal -1, then I'm gonna do this and this, and then decrement pointer. And then there might be a situation when the pointer is pointing on the dot, yeah. And like in case like pointer 1 or like they're gonna point on a dot in the same time. So I'm gonna have this if pointer 1 greater or equal 0, and let's say argument 1 pointer 1 is equal dot. I'm gonna just let's say we have result equals empty string initially, and then I'm gonna populate the dot with result, and then I'm gonna increment the pointer 1 plus equal 1, and then pointer 2 plus equal 1, and then continue. And then in case it's not equal dot, I just need to update the current one with mod 10 digits mod 10. So I'm gonna be res plus gonna be res digit mod 10, and then I need to convert that to character. Yes, it's this function char is, and then plus res, and then yes, this one. And then I need to update the carry, and then be carry divided by 10. This should be it, and then in the end I need to return result. And the question is, am I allowed to return at least? I guess you already mentioned that I can return trailing 0.
Yeah, it's fine.
Okay. Okay. So let me try run and see if I missed anything. Are you okay with that?
Yeah.
Okay. So in this case, it's a little bit long. Let's change it to a shorter one.
Sure.
Let's say we have arg1 and arg2 here.
And you don't have to write all the variable names you can just talk about it if you want as well.
Yeah. So the find will return the index of the first of the first and only dot. I assume that this is valid arguments. Again, like if not, please call out. And here the dot index gonna be 0, 1, 2, 3. So the index 1 gonna be 3, and then index 2 are gonna be again the same 3. And then 0, 0, 1 gonna be so I'm not adding dot 0 to any of them because like they already have dots. So I have I have 0, 1 that have not been calculated, and then I assume that it's calculated. So 0, 1's gonna be, as I said, len arg1 gonna be 0, 1 or so it's going to be r len of the arg1 minus 1 minus index 1. And if we don't find it, let's assume the find function returns minus, or it can, like I was saying that it returns none. Let's assume it returns minus 1.
Let's just, I get what you're saying. You can skip this part. It's fine.
Yeah,
I'm not going to worry about like, obviously you can check for none first. It doesn't matter.
And then like if it's, I'm contradicting here myself. If it's none, 0, 1, and else I can do something like this. 0, 1 equals.
Yeah, you could throw them in the else. That's fine.
Yeah. And then else.
Okay.
To like this, and then I wiped down 0, 1 equals 0, 2. Also like this. And so like in this case, both of them are going to be populated, and the number of zeros is going to be for the first one going to be length of arg1. So length of arg1 is 5. 5 minus 1 minus 3 is going to be 1, and 0, 2 going to be, so here we have 7 characters length. 7 minus 1 minus 3, that should be 3. And it's matching what we have. And in this case, we have 0, zeros 1, less than zeros 2, so it's going to be this branch. So I need to add zeros, number of zeros 2, add zeros 2, and then if while it's greater than 0, I need to add zeros to arg1. So I'll be adding like 2 zeros to arg1, so it will become something like this, 0, 0. And then I'm gonna start iterating this, applying this carry thing here. And then while carry is greater than 0, or pointer 1 is greater than 0, or pointer 2 is greater than 0. So initially pointer is going to be pointing like in the end to the like least significant digit. And then I'm going to update the result. The result is somewhere. Where is the result? Yeah, result is here. So I'm going to update the result. I'm going to check if there is a dot. And if there is no dot, I'm going to just have this carry. And then if the pointers are not, pointer 1 is not equal to -1, I'm going to convert the current pointer, current character that's like pointer 1 is pointing at to the integer and add it to the digit, and then the same do for the pointer 2 and add it to the digit, and then add the whatever is remain like you may mod 10 to the current res, and then divide the carry by 10.
Yeah, so I'm happy with that. We don't need to go into like exact like line by line there. So let me ask you a few questions just so we don't run out of time. Number one, so on line 86 and line 91, do you see a problem with what you're doing?
Let me think about. Not really. Right
So
now.
if I do, so let's say one number is like, okay, so let's say I have a string that's 1,000,000 characters and I add a 0. What's the time complexity of that?
So I'm rewriting every time I'm recreating a string. Yeah, the time complexity gonna be of whatever million. Yeah.
So how can we? You don't have to change the code, but how can we improve that?
So I can convert this arg1 to actually array. Yeah, and add zeros to the end of the array. So I can convert convert string into the array of characters, and then add the zero instead of re-adding it back to the string and recreating the string, because like in Python we recreating everything. It's not mutable. Strings are not mutable in Python.
Yeah.
So instead of doing this expensive operation, I can initially convert do something like this: list arg1, and then overwrite it like this arg1 equals like this.
Yep. And then you can just add 1, and then you can join. Okay.
Yeah.
And same thing for your result. So I don't know if you know this. If you do character of a number, like for a character, do you have to give it an ASCII value, or can it convert? I'm not sure. So I don't know if that works or not. I mean, I guess you can look at that up. I'm not 100% sure.
Yeah. I guess you are right. This one will require like ASCII character, because like there is like order that's gonna convert string to the ASCII, and there is a reverse one that's gonna convert the ASCII to the string.
Yeah, I'm not 100% sure, so you could play around with that. But let's go to the next problem just so we don't run out of time.
Sure.
Okay, so and we'll go 50 minutes just because these are a little bit longer.
Yeah, sure.
So we have another 20. Okay, so this one I didn't make up. So this one is a direct. Okay.
Okay, let me quickly read that problem. Okay, so we have a chocolate, and it has some chunks. Each chunks it has like own sweetness that's recorded in this array. I want to share the chocolates with k friends. That's k is given. So I want to have this k cuts, chunks, and I cannot like the order matters, and I cannot like cherry pick this chunk.
You can see in the example like it has to be a consecutive chunk. Yeah.
Okay. So here the k is equal 5. It means that I have 5 friends. 5 friends. I don't understand why there like should be k plus 1 pieces. Because you wanna share it with your friends and you wanna also eat, yeah, it's like that. Each piece consists of a certain each. Being generous, you will eat no sweetness and give the other pieces to your friends. Find the minimum total sweetness of the piece you can get by cutting the chocolate bar. So the first question I got, let me just check the answer, the input and output, because I don't understand right now what does it mean, like cut it optimally. So here we have 5 friends and like myself, and I'm cutting this chocolate bar in the pieces, and they are consecutive. So like you have like this part, and like so on and so forth. And then I wanna find the maximum total sweetness of the piece you can get by cutting. Okay, so I wanna get the
So basically, like
6.
the total is like, so of each of these chunks, if you add up all the numbers, that's the total, and you're giving
Okay.
yourself the least. So like in this case,
Okay.
you get 6, 9, 6, 7, 8, 9. So you'd give yourself 6, which is the
Okay.
most you can give yourself. So basically, it's like after you divide, what's the sweetness of the smallest piece, and you want to maximize that. If that makes sense.
Oh, and smallest, you mean like the least
The
number
least
of
total.
chunks? Oh, least. Okay.
Yeah. So like you just add up all the numbers in a piece, and then you get the least one, and then whatever you try to maximize that. So there's no better way to divide it with giving yourself like, with having the smallest piece being 6. Like you can't have the smallest piece being 7, for example. There's no better way.
Smallest and smaller. What do you mean like smallest? Smallest is like the least number of chunks, yeah.
So every chunk has a total, right?
Yeah.
And you give yourself so you take all the totals and you give yourself the smallest one.
Okay.
And you're trying to maximize that. So like split it in a way where you get the smallest total, and that's as big as possible.
That sounds like so. Can I have an estimate for the size of this array of sweetness array?
Yeah, so it's just really big, like million, 5 million,
okay.
whatever, really big.
So okay. 10 to the power of 6. That's interesting. So I was thinking about like whatever I can apply as a brute force here, and it seems like I need to, as a brute force, I need to select k cuts, and they can be like, so basically k cuts, it means like first I have how many places I have like n. So I have to, so it's like close to factorial. There, I should still like account for the, like, if I cut it like too wide, let's say.
Yeah,
I
you
will
can't have a factorial solution.
Yeah.
Obviously, with this.
Yeah. So like naive brute force solution will give me kind of, so the brute force, like it's cut or like
cut in every way possible, and then look for the smallest total.
Yeah, figure out what's the valid one when like I have like six chunks, yeah, because they might be like not 6 chunks or like k chunks or like k plus 1 pieces. They might be not k plus 1 pieces, and in this case, I should like in this n factorial, some of these combinations will have k plus 1 pieces, and only select those that have, and then like check what the minimal sweetness I can get, yeah, something like that. That's an interesting question. How I can optimize it, because the time complexity hints, or like the size hints me that it should be somehow linear or long linear at best.
Yeah.
And
can we do linear or long linear anyway?
Yeah. And then it means that the space of the solution, like it seems like I have either the option to, actually, yeah. So like initially I started to think about greedy solution, but it seems like if I sort it, it might give me some benefit when like all the numbers are ordered, and
okay, and how would it give you benefit? So you still have to make it so like the chunks are contiguous. Like this is sorted in this case, but yeah.
Yeah, I cannot do that. Yeah, so like I'm more like inclining to thinking about like how I can do that gradient, like let's say I have a pointer, and I kind of move the pointer and to decide whether to make a chunk or not. Yeah, or not yet. And I need to, first of all, to end up with k+1 pieces, and then that I need to find that those pieces you can. And I also need to maximize the smallest aggregate chunk.
Yeah.
Or like smallest aggregate. Like I need to maximize the sweetness of the smallest. The smallest sweetness, like I feel like
so because you need to maximize the smallest sweetness, is there any way we can like restate the problem or look for something like, it's like, we can't have a sweetness that's like smaller than whatever. So can we use that in some way?
Yeah, you're hinting me that it's like should be more like binary search solution. Yeah, and when like I figure out this level, I try to like form the chunks so that the maximum sweetness, or like if I pre-select the level, some kind of. So in this case, let's say we have this input. So I preset the level on which one I should break their.
So what do you mean by the level? Like the maximum sweetness or whatever, or what?
Yeah.
Sure.
And then if I have this criteria, so like I have like 1, and then it's still not enough, and then I have 2, and then still not enough, and then I have 3, and that's already is like 6. Let's say I have a level equals 6, and I do that kind of. I can pre-select level with a binary search, and then I can go through this array, and then like as soon as the aggregate number of pieces is equal or greater than 6, I make a cut. Yeah. And then let's say I go further, and then I choose 4, and then 4 is still not enough to add up to 6, and then I move further, and I have 4 plus 5, and then it means like it's 9, and then I made a cut. And then next one, I have 6, it's already equal level, so I made a cut, and then 7 plus 8 plus 9. That's 7 is already have a cut, and then 8 have a cut, and then 9 have a cut. The question right now, I need to figure out in which case. So like I have a range. Let's say we have some. So the possible range is 0 to whatever, like big number. And then I need to figure out like in which case I need to move to the left in the binary search, and in which case I need to move to the right. Yeah. So so if I have like a biggest, like the huge, like the highest level, let's say impossible level, it means that so starting, let's say, from a very small level, yeah. So so my point is that there will be some kind of this idea that on some levels, like starting from like the smallest one, I will be able to get the split. Yeah. So like I need to get, in this case, I need to get 6 chunks. Yeah. No, 6 pieces. I need to get 6 pieces. And then if I select like very small level, let's say level 1, yeah, I will definitely be able to split this sequence into like 6 pieces. Yeah. And that means gonna be success. Yeah. And then I'm gonna try to increase the level from, let's say, from 1 to 2, and then check if on that level. So I'm increasing like gradually right now instead of like doing binary search.
Sure.
I'm like trying to figure out like what I'll explain my idea. So I try to change it to 2, and then like again trying to split this array into pieces. And then if I can split it, okay, that means I can move further to the right. And then there will be some time when I have like pretty large level, and in this case, there will be a situation when some of the friends will be left without pieces, without chocolate. So in this case, I'll say, okay, there is no solution for this one, and I should sort of like moving right, continue like moving right. It means that by the end, it's going to be still 0, 0, 0. So there is a certain cutoff point when 1 becomes 0, and I want to take the first one, that like the last one, and it's going to be the valid solution for my for this problem.
Yeah, so to restate like the biggest number that this works for, right?
Yeah.
So I have a couple questions for you, and we can just talk about this in terms of like yeah, we could just do like a good explanation because I don't think we have time to code. So so there's like a couple solutions, right? So when you do this like check, so like in your example with 6, you got 6 pieces. What happens if you get like 8 pieces? What happens if you get like 4 pieces? Like what would you do in either of those?
So what if I have 6 pieces, let's say 6, do you mean sweetness or like pieces?
No. So in this problem, right, you need to divide it into 6 pieces because k is 5. What if in your solution here, you were able to divide it into like 8 pieces, right? Like if you try like level 1 or whatever, like level 1, you would get like way more, right? You'd get like all this.
So we can unify those pieces, and then like feed the friends with the chocolate, and I can always kind of unify the chunks and give it to the friends, so it's still going to be a valid solution.
Okay, so you're saying if you get too many, that counts as valid, basically? Okay, and then what happens the other way where you don't get enough?
When I don't have enough, it means that I don't have like enough. So like some friends are left without chocolate, and this means like it's not a valid solution, and it will be like a 0.
Okay.
Like here.
Why don't we just code the? So you're gonna have this like checker function that's gonna check like, is my guess valid, right? Why don't we just code that part?
Oh, okay.
Or you can code the whole thing if you want, but
yeah. I can code it. So
we have like 4 minutes left. It's up to you.
Yeah, bad, good. I wanna like turn on my fast mode.
Okay, we can go like 5 minutes over. It's fine.
Okay, so I'm gonna have a while bad, a while good. So good gonna be on the right, minus bad is greater than 1. I'm gonna do middle equals bad plus good minus bad over 2. And then here, so the bad is actually the index, and then it's not an index, it should be the sweetness criteria. And I should like then I have this function that I'll say check, and then I'll have this list as, and then okay, and then say level, and then it can be int, and then it's gonna be return bool. And then for the check, I'm gonna go for, so let's call it, let's return false as it now.
Sure.
False, and then I'm gonna check call check for the level m, and then for the array, and then for the k, and then if this one is true, then I'm gonna go middle equals. So I want to go to the right basically. So I wanna say bad equals middle, and then else good equals middle, and then in the end I wanna return. So it might be situation when like this array is not valid, and the bad is equally pointing to the -1. So in this case, if bad is pointing to -1, I'm just gonna
So how can it not be valid, like ever?
Let's assume we have like just sweetness equals like 1 sweetness array equals just 1 million or something like that, and k is equal to.
Oh, so you don't have enough pieces, I see.
Yeah.
Okay, sure.
So if bet is equal -1, so I'll so if it's not equal -1, I just return so what should I return here? Let me check. So output should be find the maximum total sweetness of the okay. So the maximum total sweetness. So I know that the level gonna be the issue right now. I don't know like quickly out of my head if I can reach that. Like it might be equal or greater that that level that I pre-selected. Yeah. Let's put it like this. So I want to return just bad. And then otherwise I'll just return -1 else. And then for the check, I wanna check if I can split this array into k plus 1 chunks, so that every chunk is should have at least level sweetness. So I'm gonna go for, let's see, car equals 0, and then for I in reach. Gonna go if for car plus si, and then I'll have the counter for 0, and then if current is greater or equal than the level, I'm gonna counter plus equal 1, and then and then counter plus equal 1, and then if counter is greater or equal k plus 1, I'm gonna return 2, and then in the end here, I'm gonna return false, something like this.
Okay, so counter plus 1. I see. Okay.
And I should return. Let me double check what I will be returning here. So I should return the output. Find the maximum total sweetness of the piece you can get by cutting the chocolate bar optimally. So the maximum sweetness. The only question I have in my head is like, I think like I have the intuition that in case like I will always can expand this one solution if like let's say I have like let's say levels equals 5, yeah. And then I need to level have actually 6, yeah. So like if I have like valid solution for level 5, I can expand it to level 6 until I reach the exact value, yeah. So I feel that this should work.
Okay. Okay, I think we can stop. We're a decent bit over. So, all right, so let's go back. So first of all, how do you think you did? What parts do you think you did well? What parts do you think you can improve upon?
So definitely I spent quite a lot of time on the first task, and doing maybe tracing, paper tracing, and like ensuring everything is like tip top. And like the first solution was a bit verbose, and I took a little bit like credit for the time for the first solution. And that's basically the second problem was a little bit harder. I wasn't able to like map it like initially to the solution and like figure out that it's kind of binary search. So like I already spent some mental energy like on the first solution and overspend it, and then underspend on the second one.
Yeah.
So that's...
Okay. So what I wrote is, yeah, so for the first one, you restated in your own words. You definitely asked about like inputs, edge cases. I think you missed the negative one, but you got all the rest. Like you were pretty thorough in terms of like what are all the different things that can happen. So that was good. Yeah, basically your like idea that you had was fine. It's easy to follow. I think the main thing I would recommend for you is obviously like time. Like you plan, but it's almost in like too much detail and too many. It's like if I'm giving you this problem, I'm familiar with the solution, right?
Yeah.
So
Yeah.
you don't have to go in like extreme detail, and also you have a clock, right? So
Mhm.
this was 53 minutes. You know, for most like
Yeah.
companies, like you get like 2 questions 40, 2 questions 50. So definitely
Yeah.
try to like speed up and not focus so much on the super small details.
Mhm.
And just try to explain it and then be like, hey, are you good, or do you want me to go in more detail? And
Yeah.
then if I want you, like I've had people that I did mocks with that I couldn't really tell what they were thinking, and they said something, and I'm like, I'm not really clear. Can you go in more detail? And then I asked them. So
Mhm.
that's what I would recommend, because like at the end of the day, right? We went over. At the end of the day, if you have 40 minutes, people aren't going to be like, all right, let's just keep going. It's going to be like, nope, sorry, you got to the second problem and you did like 2 minutes of it, so we have to cut it
Yeah.
here.
Yeah.
So
Yeah. That's true.
so it's kind of like the system design stuff. Like if you don't have a working solution, the stuff you did could have been really good, but you need to at least like finish, you know?
Yeah. 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 That's
Okay.
true. So I would be like in a real coding drill, like for FAANG. I will be
Yeah, you
probably in the
definitely need to
middle of
watch your time.
implementation of a second one. And they would cut me off.
Yeah. For what it's worth, so this first one's kind of a pain and the second one's a hard. So for what
Mhm.
it's worth, this is like a harder interview. So I think if you can like, if you would have crushed this one, that I would have been like, yeah, absolutely, you can do whatever. Like
Mhm.
because this decimal one is kind of a pain. There's like a bunch of things you have to do. You did come up with a
Yeah.
really good. Honestly, I would say like out of all the things I've seen with this problem, this is probably like optimal. Like normalize, add them, and just ignore the decimal. It's like the cleanest
Mhm.
way to do it. So that was good. Yeah, you talked about what you were writing. Yeah, like you mentioned, your code was a little bit. You were like, I noticed you were like, oh man, I have to check if like one has more and then the other one has more, and I'm gonna have all this stuff. So I kind of gave you a hint of
Yeah.
like, you can just do this because I knew we were gonna like run out of time if I didn't. So
Yeah.
definitely
Yeah.
some things
That's
like
true.
that. Try to find like, how can I write like not the least code and then or not the most code and then like write it quicker. Um,
Mhm. Mhm.
so yeah.
Yeah.
So I think a big thing I focus on is like code quality, and maybe a lot of people don't focus on that. Where it's like, yeah, you can do a solution, but like, is your solution readable? Did you write it in a good way? So I always usually do the problems, and then I go and like refactor and see like let's say you had this, for example, I'd like feed it into GPT and be like, how can I write this in a better way? And you just do that
Mhm.
enough times, and then you start seeing patterns of like, oh, instead of checking for all these things, I can just like add a decimal to them, and then in every case it's the same. You could have
Yeah.
even done like more, I think, here,
Mhm.
where you didn't even need these like indexes as none. You could have just had uh some easier way to write this as well. And then
Mhm.
also, yeah, I think this whole thing honestly could be cleaned up into like half the code.
Yeah.
But obviously you don't want to overcomplicate it. And then the other big thing is, yeah, you and I think this trips a lot of people up is in Python, strings are immutable, so doing the while thing is not
Yeah.
great. You could have also just added like a 0 times whatever your thing is in Python, so
Mhm.
instead of the
Mhm.
while, but that's whatever, it's fine. Like I think like if I tell you what's the problem and then you can like figure it out, then it's good enough in my opinion. If I tell you what's the problem and you, well, I think I actually had to give you a hint, so maybe it was like a little bit bad where I'm like, what's wrong with
Yeah.
this, and you
Yeah.
weren't sure. Yeah, so
Yeah.
that's definitely
Yeah.
one thing I'd watch out for sure. And like string problems is don't do stuff like this. Use an array. And
Yeah.
then let's see. There, yeah, your carry stuff is all fine. Like this is all fine. So for the first one, I said, so your problem solving, like, so this was out of 4. You basically came up with like the best thing you could do. So 3.5 out of 4. I wrote coding ability was a 2 just because there's a lot of things you could have cleaned up, and I gave you some hints. And then
Mhm.
DSA was a 3, and communication was a 4. I think DSA could have been better if, like I said, you didn't do the string stuff. The other thing you could have done that would have made it easier for you is you could have done like a reverse, and then you wouldn't have to do all that backwards stuff. That's like another common pattern is
Yeah.
like
Yeah.
if you
Yeah.
reverse, then now it's really easy to find stuff, and it makes more sense in your head. Um,
Yeah. And also I'm thinking right now about generators like for adding like this having this while loop, like I
I mean,
can
you
have
can
like
basically just do like
comprehension.
you can just do like a string plus. I think you can do this in Python,
Yeah.
like, and that works, and then you'll just
Yeah.
like
Yeah.
so
Yeah. Yeah. And
yeah
if the string is just array, you can do the thing.
yeah. Okay.
Uh,
Let's see. So yeah, I'd say this one was like a lean higher, but definitely could have done better. And then the
mhm,
second one, so you restate the problem once again. So the second one, you didn't ask about edge cases, but you kind of handled it. Mainly the one with like, what if you don't have enough pieces?
mhm.
So I would have been good if you asked that. Yeah, I did give you a hint for the binary search. You're going the wrong direction, but it's hard. So like, I think it's fine for me to give you like a small hint. You were kind. Also, the other thing, realistically, you're never going to be given this in an actual interview. Like, if you ask for a constraint, like you can't just like look at a number like leak code. You know, you can't be like it's 10 to the 6, so I know I can't do n squared or whatever. They're just going to say it's a big
Yeah.
number. Um, so I wouldn't even bother, honestly. Like I mean, you can ask like, is it a massive number or is it going to be like 20, and then you can cut
Yeah.
out like the backtracking or whatever. But
Yeah.
usually they
Yeah.
just don't say anything. Like you can't do that.
Yeah. Yeah.
So
That's a trick. Yeah.
yeah, I know it works in like leak code and like assessments and stuff, but it doesn't really work. Yeah. So okay. So yeah. So you figured out the binary search thing with a small hint. I feel like I didn't give you that much. I was just like, well, you know, the maximum is this, so how can you restate it to like, you know, do this, and you figured it out. And so that was good. Um, Once again, though, it took you a long time to make the plan. So ideally, like time wise, you want to be like 1 to 2 minutes, read the problem, ask clarifying questions. Five or like, you know, maybe a couple more if it's more complicated. Like this one was more complicated, so maybe like 5 minutes. 5 minutes ideally, come up with a plan, and then
Mhm.
like 10 minutes code or like 8 minutes code and like 2 minutes dry run or something. So then you're at 20. The other thing
Yeah.
is for a lot of these, they give you two problems and then they give you 40 minutes. So if you finish one faster, then you have more time for the second. Both of these were kind of a
Yeah.
pain, so you didn't really have that.
Yeah.
Which, yeah, but that's fine. I do think like if you get asked harder stuff, there's more leniency, right? If you get asked like two sum or whatever, like
Yeah.
you better solve it perfectly. But if you get asked
Yeah.
harder stuff, there's more room for error.
Okay. Yeah. Yeah.
Let's
Makes
see.
sense.
So yeah, so definitely longer. And then yeah, also the binary search thing. So first of all, you had a bug somewhere. Oh, you have to like reset your counter, but you probably could have figured that out in a dry run in
Mhm.
the check thing. Um Also, this was kind of weird. Like I've never seen a binary search like this. Like it was, I mean, honestly, being the interviewer side of this, like having people write binary search in like 10 different ways, I'd be like, I don't know if this works. Hard to say. Like, because I know how I write it and I've never seen it like this. I also don't think so. Let's say, like, for example, let's say bad was like 3 and good was 4. You would just
Mhm.
get 3 all the time, right? And then you would just say, like, and then you would just reset this. So if this worked, you would just reset bad to 3 again, and then you get 3 and 4, and then you'd reset bad to 3 again, and I think this would be like an infinite loop.
No, the delta gonna be equal 1, so good minus bad gonna be great.
Oh,
It's more like
greater, I
about,
see.
yeah, yeah. It's more about indices. I didn't do that. Yeah,
I
correctly.
see. So it's still, I see. So if they're 1, then it would still be fine. So if it was like 3 and 5, okay,
Yeah,
now it would move up.
yeah.
I see.
That's right.
I
It's
see. Okay, that makes
it
sense.
should be more like indices, and yeah, I
Yeah, I think
probably have
normally
some
I
bugs
see
there.
it like left is less than
Mhm.
or this way. I do it this way because it's very clear, but yeah, personal preference. This makes sense then. And I think the other bug you had was here, so I think you needed to return good, I want to say. Because you like never return the good thing here.
No, good is pointing at should be pointing at zeros actually.
Oh, I
Good
see.
should
Oh,
be,
so bad is the correct one. Bad is like the
yeah.
final one. Okay, that makes sense. Yeah, so for that one I'd kind of have to like obviously if you can't run your code, you know, it's hard for me to tell like
Mhm.
but this is fine. I think if you basically if you had time to dry run with an example and your numbers were good, like this would have been good to dry run and then I could see like, oh yeah, this worked out. Then I'd be
Mhm.
happy with it. So overall, I think the main thing is just speed. Like I said,
Mhm.
you know, you everything is pretty good. Your code quality is pretty good. Your algorithm knowledge is pretty good. Like I don't think it's easy to find a greedy binary search relatively quickly, even with a small hint.
Mhm.
So basically, for the third one, I gave you a 3 for your problem solving. Honestly, I feel like the coding ability could go up to like a 3. Like, yeah, you did have small bugs, but I'm pretty sure this works. DSA 3 because I had to give you a hint, and communication 4. So yeah, I think your
Mhm.
strengths are DSA. and communication. Like it's very easy for me to tell. Like I almost want to cut you off a lot of time where you're like you explain it and then you go in depth. I'm like I really don't need this in depth thing. Like I totally get where you're going. You can just go. And then the weakest things is like time, and then probably like clean up your code a little bit. But overall, I'd say this would be like a lean hire type of thing. I would assume. You know, the numbers are a bit low, but these are harder problems, so I think that's pretty fair. Like, let's see, for the first one, I'd say the average is like a 3 out of 4, which is still like a lean hire, and then for the third one, it's like a little bit higher than a 3. So yeah, and for what it's worth, I do think that like if you get asked 40 minutes, the average difficulty of the problems will be easier than this. So yeah. So I mean, obviously you don't have a lot of time to prep, but I think you'll do okay.
We'll see.
There is a lot of, I will say, with the problems,
I still have a night before that.
I will say, like, there's a ton of variance on what you could ask for like all the companies. It's almost kind of unfair, you know. Like, I've seen people get asked some ridiculous stuff. I've seen people get asked like super straightforward stuff. So there's a lot of luck there. So it's like, if you're just crushing hards, then like no matter what you get asked, you're fine. If you're kind of like probably gonna pass, you can still get like super unlucky and stuff. So yeah,
and like this number, like the more you try, like if I go to interview day, it's gonna be just more problems, and like if I have like some chance of solving the problem, if I have like more like problems, it means that like passing overall is gonna be a little bit lower than on screening, because on screening you have like two coding problems, and on interview day you have like 3 interviews, like 2 coding problems each.
So I didn't always, but I usually tried to split them up for most companies just because it's kind of draining. Like I don't want to do 4 hours back to back to back to back. So usually most companies let you, but also if you're like working and sometimes your schedule and like, so some of them I've had, actually for the job I have now, at a FAANG, I didn't split it up. So it was all back to back to back to back, and it was fine. But for most, I split it up. So yeah.
I made this mistake when I was. I didn't split up. Oh, like actually, like one FAANG company, like I split up, and like the last interview was the best one. I was relaxed. I solved and nailed it. But the previous one, it was the last interview during the day. It was like 2 sys designs, while 2 coding interviews, and the last coding interviews I completely bombed it.
Yeah, because it gets pretty tiring. So yeah, for sure. But yeah, best of luck. Let me know how it goes. Curious to see how you do. I feel like you'll do pretty well. Like obviously there's luck. Like basically it's like I feel like there's like a probability you'll pass whatever, and then like the more prepared you are, the higher it is. So you still get some luck. So
there's still a chance in this game.
Yeah. But yeah, best of luck, and let me know how it goes.
Yeah, thank you. And you said that it's gonna be published on your YouTube channel?
Yeah, so I'll publish it. I usually do one a day, but I didn't do any other ones today, so I'll publish it in like an hour. Yeah.
Okay. Cool. Great to hear that.
Okay.
Yeah, if you, I don't know, like what's your load, probably if gonna.
So I had on my schedule, I had two slots a day, but I have work as well. So I made it go down to 1 slot a day, and then like I have like 5 slots on the weekend every day. So usually on the weekend I do like 2 or 3, and then on the weekday I do 1 or 0 now, and that's like pretty
because
good.
I scheduled something for tomorrow, and I don't know, like should I cancel it? Like it depends on what you want to say.
Yeah, well, up to you. I mean, if you want to do it, totally fine.
Yeah,
if not,
sure. I'm more than ready.
Okay, sure. Then in that case, happy to do it tomorrow. Yeah, I'm fine with that. Cool.
Yeah, sure. Okay.
Thank
you, Anatoly, for your time and efforts and feedback.
Okay, thanks. All right,
have a good night.
Bye.